I welcome you all for this presentation. In this presentation, we are going to discuss about Euclidean algorithm, and here we are going to solve a problem using Euclidean algorithm. So before solving a problem, we have to understand what is the need for Euclidean algorithm and what is Euclidean algorithm. So here we are using Euclidean algorithm in order to find the GCD of two numbers. So GCD means it is a greatest common divisor. All of you in your school days, you have calculated this greatest common divisor, but not with respect to Euclidean algorithm. You are just finding out the factors and you are taking the common factor and you are finding out the GCD of two numbers. Here we are using one theorem in order to calculate the GCD of two numbers. That theorem only we are calling it as Euclidean algorithm. So here this GCD of A comma B is computed as GCD of B comma A mod B. So here what is A? A is a dividend. So if you are dividing two numbers, we are having two inputs. One is dividend and another is divisor. So dividend only we are calling it as A and the divisor we are calling it as B. So repeatedly we are calculating the GCD and finally we are finding out the GCD of two numbers. So the function is Euclid of A comma B. So if B equal to 0, we are returning A, and else return Euclid of B comma A mod B. Mod, all of you are aware, the remainder you are finding it out, and repeatedly we are performing. So before proceeding to the problem, we can see the flowchart of this particular algorithm. So we are just starting, and first we have to check whether A is greater than B. What is A? A is dividend and B is divisor. So if A is not greater than B, what you have to do is you have to swap A and B, because always the dividend must be higher than the divisor. That condition is very important, right? So first we are checking A is greater than B. If no, we are swapping it. If yes, what we are doing is we are dividing A by B and calling the remainder as OR. Then we are checking whether the remainder is greater than 0. If no, what we are doing, GCD is the final value of B and we are ending this particular algorithm. Suppose if R is greater than 0, it is yes, that means remainder is greater than 0. In that case, what we are doing is we are replacing A with B, then we are replacing B with R, and again we are dividing A by B and calling the remainder as R and again checking the condition. So once the remainder becomes 0, then only we are stopping it and we have obtained the GCD. Let us see the example. So here we are going to solve one problem using Euclidean algorithm, that is compute GCD of 2740 and 1760. So now you know that 2740 is the dividend, so it is A, and 1760 is the divisor B. So what is the first condition we have seen? Always we have to check A is greater than B. So A must be greater only. So suppose if it is not the case, we have to swap. Here A is greater than B. Yes, condition is true. So we are just dividing A and B. A divided by B. So the dividend is 2740 and divisor is 1760. Here the quotient is 1 and the remainder is 980. Normal division you have to perform. Now what we are checking, whether the remainder is greater than 0. Yes, condition is true. So what you have to do, replace A with this B. So 1760 and B becomes R. We are replacing B with R. So it is B equal to 980. 980. Then again you are performing the division. So quotient becomes 1 and the remainder becomes 780. Again you are checking the remainder is greater than 0. Yes. So we are replacing B with A, that is A with B, that is 980, and B equal to this R, 780. So again now we are dividing, the quotient becomes 1 and the remainder is 200. R is greater than 0, condition true. So now A equal to 780 and B equal to 200. Now quotient is 3 and the remainder is 180. Now our remainder is greater than 0, condition is true. So what we are doing, now A becomes 200 and B becomes 180. Now we are dividing, quotient is 1 and the remainder is 20. R is greater than 0, so condition true. Now A becomes 180 and B becomes 20. Now we are dividing 180 divided by 20. The quotient is 9 and the remainder is 0. Now R greater than 0 condition we are checking. R greater than 0 condition false because R equal to 0, right? So if R equal to 0, what do we have to consider? The B is the GCD. The answer is 20. So the GCD of 2740 and 1760 is 20. So for your ready reading, it is given in the table. All the values are given. The GCD of 2740 and 1760 is 20. So this is very simple. So using Euclidean algorithm, you can easily compute the GCD of two numbers. I think all of you understood this algorithm. Thank you.